Hello, this is Ms. DB, and in this video I'm going to review how to do some of the problems from the Factoring Review Number 1 worksheet in Algebra 2. This should be a review from Algebra 1, but for some of you it may be it's been a while since you've done this, or maybe you didn't quite get it the first time around. So to start with, we're just going to review how to factor polynomials by factoring out the greatest common factor. That's what GCF stands for, greatest common factor. GCF for short. GCF. And we're going to first figure out what is the greatest common factor, and then remove it from each term by dividing it. So it's like the distributive property in reverse. So again, our first step is to find the greatest common factor. And we do that by finding the greatest common factor of the numbers 15, 18, and -6, and then figure out what variable can also be factored out. And we use the lowest degree of the variable that is in each of them. So to find the greatest common factor of 15, 18, and 6, we can list the factors. 1 times 15 is 15, and 3 times 5. So these are the factors of 15. Factors of 18, there's a few more. We can do 1 times 18, 2 times 9, or 3 times 6. Those are all factors of 18. And then 6 is a little easier. It's just 1 times 6 or 2 times 3. Look for common numbers that appear in every list. And you can see that 3 is already circled. That's the common factor for the coefficients. Now there's also a b squared in every one. There's a b squared and a b cubed and a b to the 5th. Only the b squared could be factored from each. So use the lowest exponent on a common variable. If there was not a b in every one, then you couldn't use the b squared as the common factor. So we put those two parts together, 3b squared. That's our greatest common factor. That's our GCF. Now that we know what the GCF is, we're going to put that in front and then figure out what is left after you divided each term by that. So here's how I do it. And I would do this on my own paper or off to the side. You don't have to show me this step. But once you figure out what is the greatest common factor, then you are going to divide each term by that. So our original problem was 15b to the 5th plus 18b cubed minus 6b squared. And I found out that the greatest common factor was 3b squared. I'm going to divide every term by 3b squared and see what I get. So when I divide 15b to the 5th by 3b squared, 15 divided by 3 is 5, and b to the 5th divided by b to the 2nd, the rule is you subtract the exponents when you divide, or you can think to yourself, that means b times b times b times b times b, that's b to the 5th. B squared is b times b. So did I write? Yeah, I wrote that right. So 2 of the b's will cancel, and I'm left with b cubed. Or you can just do 5 minus 2 for the exponents. And then I have to divide the second part by 3b squared. So 18 divided by 3 is 6. B cubed divided by b to the 2nd would just be 1b left over. B to the 1, or you can just write b. Oh, and this one's a minus sign, not a plus, because it was minus 6b squared. So minus 6 divided by 3 is 2, the coefficient part, and b squared divided by b squared cancels, and there's no b's in that part. Now don't forget that you also have to write your greatest common factor in front of this. That's part of the answer. So this whole thing is that polynomial factored by the greatest common factor. All right, let's look at what you will be doing on your worksheet. So these problems are all similar to what we just did. If you are going to print this worksheet out and do it, I highly recommend hitting enter a couple times between each problem so that you can have a little more space. I was trying to get it all on one page, but that doesn't work very well if you're printing it to do it. All right, so now you're going to first figure out what is the greatest common factor. So our number parts, the coefficient part, is the 4 and the 12. Let me write the 12 below that. So the factors of 4 are 1 times 4 and 2 times 2. Don't write the 2 twice, just write it once. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4, because 3 times 4 is 12, 2 times 6 is 12, and 1 times 12. Now find the greatest common factor that shows up in both of them, and it's 4. So we know the number part is going to be the 4. Now we look at the x's. We have an x cubed and an x squared. They're both x's, so that's nice. Take the smaller exponent, x squared. So our greatest common factor is 4x squared. Now, what will go inside the parentheses is what you get if you take the first term, 4x cubed, divided by 4x squared, and the second term also divided by their greatest common factor. So 4x cubed divided by 4x squared. Well, the 4's cancel. X cubed divided by x squared is the same as x times x times x divided by x times x. 2 of the x's will cancel, and I'm just left with 1x. So that's all that I have for the first term left over. For the second one, the x squareds are both going to cancel. That's the exact same thing on top and bottom, and I just have 12 divided by 4 is 3. So that's how you would factor number 1. Now, if everything factors out, then put a 1. Don't leave it as nothing. Let's look at number 3. The greatest common factor of 9p squared plus p, well, the numbers are 9 and 1. The greatest common factor of that is just 1. So there's no number that I can factor out of the p. And then I have p squared and p. Well, they're the same variable. This is the smaller one. So the greatest common factor is just p. So now I take the 9p squared divided by p plus p divided by p. So p squared divided by p is, there's still 1p on top. So, and I still have the 9 because I didn't factor it out. So 9p squared divided by p is 9p. And here's where I was talking about if everything cancels, p divided by p is not 0, it's 1. So number 3 would factor like this, and then we'd be done. Let's see if any of these look tricky. Not really. In number 4, there will not be any variable part that will factor out because 8 does not have an r on it. So the greatest common factor in number 4 is just going to be the numerical part that you get when you figure out the factors of these. When you find the greatest common factor, then that's what you will put, and then divide each term by that to find what goes inside the parentheses. Number 11 is just an application problem. They've written that this is the expression that gives the rocket's height after t seconds. Factor this expression. This is, you don't really have to solve a problem here. It's just factoring this. So you still find the greatest common factor of 16 and 320, and then you, oh, there's a t on there, and the t will go with that as well. It's probably 16. Try that. Number 12, one of these is correct, one of them is wrong. Pick the one that's incorrect and tell it why it's wrong. And then there's a couple multiple choice questions here. This is 13. Number 13 says, what is the complete factorization of this? So figure out which one of these is correct. And number 14 is which is not a factor. So 1 is a factor of everything, so that's going to be. I don't think this one is. X plus 2, let me go back to what we wrote for number 1 that we solved. In number 3, after you do this, after you factor out the GCF, this is a factor and all of this is a factor. So p is a factor and 9p plus 1 is also a factor. These are both called factors now. So that might help you answer that question 14. And that's it on this one. It's not a very long assignment. It's just a review to make sure you remember how to factor the greatest common factor, because moving forward in this chapter, there will be times where you'll have to do that before factoring more and then finding out some information about the quadratic function that you're dealing with. All right, good luck. Let me know if you have any questions. Thank you.